There have been a lot of different kinds of bus slots. We'll start with one of the most popular that have been out there called a PCI, or a Peripheral Component Interconnect Bus. Nobody ever calls it a Peripheral Component Interconnect Bus. It's always a PCI bus. And it's the standard PCI that first came out was a 33 megahertz speed with a 32-bit bus width. And so we got a certain amount of throughput we were able to get through there, but it wasn't enough. So we came out with a new standard called PCI 2.1 that had a 32-bit bus and a 64-bit bus. So we were able to have a much bigger bus there. And notice that it used different cards that had different voltages, so different amount of power that was required. As we were getting these more advanced systems, we were getting these bigger cards, more video, a lot more power was required for them. And some we were able to optimize the power and make it so it used less power. So we needed different options. And for that, the different cards themselves are keyed depending on the type of voltage they would need. We'll look at that in just a moment. There was a newer format called PCI 2.3 where we realized the adapters we have now, we're really able to optimize a lot. A lot of the capabilities are on the motherboard. We don't need a lot of power. So we were able to create a new standard for PCI that didn't even use 5-volt adapters anymore. You see these ports, the PCI slots, the 32-bit and the 64-bit on your computer. And you can see they're different sizes, the 32-bit. Notice they're also keyed a little bit differently depending on the type of cards. That way, you can't accidentally plug in one to the other and you're finding it's not working. Well, it's not a problem. You have a key here, so you know exactly the way it's plugged in. If you're using a daughter board or a riser card, it takes that idea of being there on the motherboard and turning it on its side. And the reason we would do that is if you were using one that was in a very small system that had very, very low profile, perhaps it was being used in a data center as a server, you want to have those cards turned on their side so that you're able to have a much narrower interface. And maybe you want it longer, but much flatter. And that's why we would have these riser cards and these daughter boards. The 32-bit expansion cards themselves, notice these key pins. If you had a pin here, a slot available, that signaling key pin means that this card would support 5 voltage. This one would support a bus that was able to provide 3.3 volts. So this expansion card could fit into either one that would allow 5 or 3.3 volts. The 64-bit cards had different keyways. Here's one that also supported 3.3 volts and 5 volts. You could do either one of those with this card. There was also this spacer here, which meant that this was a 64-bit card and you had this extra interface setting off here on the side for the extra data. So just looking at the card, you're able to tell the type of interface it is, whether it's 32-bit or 64-bit. You could also tell exactly the type of power that would be required for the type of interface that you're plugging into. Before we got these really, really high-speed buses on our computers, the idea of having very good graphics really took off. It was really our gamers that really pushed the capabilities of our computers with video. And so a video format came out called an Accelerated Graphics Port Bus, this AGP bus. We almost never called it Accelerated Graphics Port. It's always AGP. And you'll look at your motherboard, and right next to that port will be written AGP. You don't really see it much anymore. We've almost moved all of our video into PCI Express these days, but these were specifically designed for graphics adapters. These were these older Pentium 3 type systems that didn't have enough enough CPU cycles on the motherboard to be able to support a lot of high-end graphics. So we created a specialized bus that was high speed just for graphics. And this is one of those cards. If we look really close, you'll even see the bus interface right here. Very, very specific. It had a little connector on it that would fit onto the motherboard and really fasten down quite well, because these were very exacting specifications to be able to have traffic and information go back and forth off that bus. It was really a really nice connector for video because for the time, it was very high speed. We really don't, as I mentioned, see those much anymore, but really useful to have back when we needed higher video. There were different formats of AGP, a 1x, 2x, 4x, and an 8x that had different speeds of capabilities through those. So AGP started off slow and it evolved also through the years to be able to support faster and faster throughputs. Notice that it also supported different speeds and different voltages, just like our PCI supported different voltages. And again, the way we designated that was with these different keyings that were in the cards themselves. That way we couldn't plug in our card and it wouldn't be supported. We knew exactly what type of voltages the motherboard would provide. Here's a picture of an AGP expansion slot right on a motherboard. Notice it's very close to the graphics chip that was on the motherboard. There's the graphics chip, the Rage Pro Turbo AGP graphics chip, and this is the AGP connection on the motherboard. Now what's interesting, as I mentioned about buses, this was a great picture for this. Each one of these pins that were on the CPU for the graphics all plugged in somehow to that particular connection on the motherboard. So you can see all of these different traces that had copper that connected these chips and these devices together. So when we talk about the bus, that's really what we're talking about, is this connection between all of these different devices, and this data would just flow over these rivers of connections onto these expansion slots that we have on our computer. So you can follow all the little traces all the way around, and we'd even have these different little squiggles down here just so we could fit everything into such a small space and have it go through our computer. And that's how we're able to transfer all of that data from one place to the other.